Okay, these are the notes for section 8.2. It's called displaying data. And basically what this is any type of graph or image that is used to represent math. So there are a lot of different types of graphs. I cannot possibly cover them all right now in a 15-minute video, but I selected these straight off of Hawks and just put them in a Word document because this is the kind of thing it's hard for me to create and draw myself. I'm not that good at typing up math. So these are directly out of Hawks. I'm just going to go over a few with you, and then you'll do your Hawks assignment. And you'll see some of these exact questions on Hawks just with different digits. So let's look at what this even is. Data can be displayed in many ways. I said that. Some examples are tables, pie charts, line graphs, bar graphs, histograms, and pictographs. Those are just a few. There are many, many, many other ways. And a graph that intentionally or unintentionally misleads the reader is called a deceptive graph. I think Hawks may use a different word in just a minute. Misleading graph, deceptive graph. So if you have a deceptive spouse, okay, that person misleads you. They're not honest. And the same thing about these graphs. If you have a deceptive or misleading graph, something about that graph, and there's a million different things that could be deceptive or misleading, but something about that graph is not completely truthful. Okay, sometimes people do this on purpose to mislead you. Sometimes it's just an accident. Okay, so let's look at some examples. The first one, the following table represents a group frequency distribution of the number of hours spent on the computer per week for 50 students. Okay, that's important. We have 50 students. What percentage of students use the computer between 3.5 and 6.9 hours a week? Okay, so we want to know what percentage of students use the computer between 3.5, okay, here's 3.5, and 6.9. So we've got 16 students that fall in there. Another thing that's important is that we're told that there were 50 total students. And if you remember a couple weeks ago, we learned percentages. So the formula that I prefer is part over whole equals the percent over 100. And that's what I'm going to use today. And again, we did that a few weeks ago. Okay, what part of the students are we talking about? Well, we're talking about 16. That's the part that used the computer between 3.5 and 6.9 hours a week. So we'll put 16 on top. The whole number goes on the bottom. So I'm going to put 50 because that's the whole group of people. I do not know my percentage, so I put an X, and all that goes over 100. Now, I'm going to have to calculate these in real time, so I've got my calculator. Here it is. I know that 16 times 100, if you cross multiply, that's just going to be 1,600. And 50 times X, 50 times X is 50X. And if you divide that up, we know that would be double 16 because 50 goes into 100 twice and 1,600. But anyway, 1,600 divided by 50 is going to be 32 because, like I said, 50 goes in 100 twice, and 16 times 2 is 32. So the answer here is 32%. 32% of the students. Now notice it says round to one decimal place if necessary. I use my calculator. I don't know if you can see that. There you go. It's exactly 32%. There is no decimal. Moving on to the next one. Oh no, sorry. The following bar graph represents the undergraduate majors. I'm not sure why, but I'm not seeing, let me see if I can move this. I'm not seeing the question that goes with this one. Oh, okay. It says use the graph to determine which undergraduate majors are less common among the 150 than classics. Okay, so we want to know what is less common than classics. Well, let me find classics. Here's classics right there. I just hit classics. So anything that is less than classics, this is classics right here. So anything that is, before that would count. So let's look at what comes before. This one, philosophy is close, but it's a little bit beyond. So we've got English. That would be an answer. English is less popular. We've got engineering. And that's all. Those are the only two that are less popular than classics. Okay, moving on. This is a map of the United States, and just be really careful that you read this correctly. It says the following map shows the growth rates for each state in the United States. Use the map to determine how many states had a below 2.5% job growth. Now, what I find people want to do here, because they see those colors, so they immediately are going to count colors. That's not a very good idea, because if you look right here, you're told there are 12 states that are blue. There are 2 states that are gray. 10 states that are orange, 11 that are green, 15 that are purple. What I find is when students just try to count them themselves, they may miss one, they may overlook something or whatever. It's better to go with the facts that are presented to you. So you don't really have to worry too much about counting here. It says how many states had below 2.5%. Okay, so that would be anybody down here, less than 2%. That includes people that are losing jobs. There are 15 states that are losing jobs. Make sure you read the question really, really carefully, because your question on the Hawks, it'll have the same picture, but the question will be different. So determine how many states had below 2.5% job growth. Well, the answer to that would be 11 plus 15, and that would be 26 states. Because these 15 at the bottom, not only did they not have any job growth, they're actually losing jobs. So they're way below 2.5%. They're in the negative job growth category. Moving right along, the following line graph. This is a line graph. So it's not like a straight line, but it's little line segments being connected at specific points. The following line graph shows the price of a stock over the previous 2 weeks. Use the graph to determine the number of days in which the stock was between 60. Okay, here's 60. See if I can draw a line. There's 60 and 70. So we want anything between these 2 red lines. Okay, so we've got, here's a dot between the 2 red lines, and here's a dot. So what that means is the answer is 2 days. There were only 2 days that the price was between 60 and 70. Okay, this is a pie chart, very familiar type of graph. Caden has accumulated $2,300 in savings and wishes to invest this money sensibly. The types of investment and their corresponding percentages recommended by a financial advisor are shown in the following pie chart. Find the amount of money Caden should invest in stocks. Okay, again, this goes back to what we studied a few weeks ago about percentages. So find the amount of money Caden should invest in stocks. Here's stocks right here. He should put 34.4% in stocks. I'm going to use the same formula that I used on number 1. Part over whole equals percent over 100. Okay, now we're trying to figure out what part of 2,300. 2,300 is the whole amount that Caden has to invest. We don't know what the part is, so we put an X. Our percent is 34, and percentage always goes over 100. I'm going to cross multiply, so 100 times X is 100X. I'm going to pick up my calculator, which I hope you have by now. 2,300 times 34.4, and that's going to be 79,120. And then I'm going to divide both sides by 100, divide by 100, and the answer is going to be, we're talking about money here, so put a dollar sign. And money should go to 2 decimal places. Now, Hawks was kind enough to tell you to round, sorry, I just made a mistake. No. This problem says round to the nearest whole dollar. I almost missed this one on Hawks, okay? Your instructor just about missed one because I did not read. So don't make the same mistakes that I just made. Read the problem really carefully. Make sure you're rounding correctly because I was not. I was rounding wrong. So let's see. Is this going to stay at $791 or bump up to $792? Well, it's going to stay at $791. That 2, since it's less than 5, it is not enough to bump up. So we have to round this answer right here to the nearest whole dollar. Let me draw an arrow from here to here because that's why I cut that 20 cents off. I almost missed that one, so be careful. Determine the following graph how the following graph is misleading. Okay, misleading means to lie. It means to be false. It means to be deceitful, dishonest, unfair. And so there are a lot of different ways that a graph can be misleading, but let's look at this one. Well, there's several issues here. First of all, I'm given a pie chart, but I don't have any numbers. Okay, what do these blue blocks mean? I know it has to do with the number of students and it has to do with the courses, but there are no numbers here. It doesn't give me any type of countable information. So what is the value behind the blue blocks? I would say that would be the number one thing that's misleading. There are no numerical, or I will say numeric labels. Another way to say that is there are no units, no measurable units, I should say, because we know the units are students, but we don't know if this is this 10 students, or is this 20 students, or is this 1,000 students, or is this one student? That makes a huge difference. We do not know. We have no numbers whatsoever on this graph, and that is misleading. Okay, so that's just one example. There are many, many, many examples of how a graph can be misleading. There are a lot of examples of this on Hawks. I think you have about 19 questions on this particular section. You're going to have pie charts, bar graphs, line graphs. You're going to see that chart of the United States of America again. Just a lot of different types of charts. You're going to have to do percentages in some questions. Some questions you're just going to simply count. I like this section because if you open up a news article, I know people don't really read the newspaper and probably not even magazines anymore. Pretty much everybody just reads information on their phone. But even on your phone, if you go to a news article, you're going to see some type of chart, some type of image that represents those numbers. So look out for that this week as you're doing this section.